This is why it's an L1. I don't know if this is counterintuitive to some people, but L1s are the cheapest way to do things in blockchain.
Ooh.
Welcome back, everyone, to another episode
Hello.
of the Spelunking podcast, where we discuss caving in the world of cryptocurrencies.
Indeed.
Every now and then I check YouTube to see what comes up when I type Spelunking, just Spelunking, and I'm always hopeful that Spelunking podcast will be number one, and it never is.
I'm pretty sure that's just them trying to keep us down, man. It's censorship is what it is.
We need a decentralized YouTube.
Right. Nobody has ever thought of that before.
Yeah, we tried to build one in 2015. For obvious reasons, the technology was not quite there. But the funny thing is, like, if we had a decentralized YouTube, like some kind of federated video platform could actually be quite interesting. But if you just had kind of like, wild, wild west, put up anything you want, it would be chaos. It would be the target of so many investigations from every country of the world. Like the only things people would post there are the things that are like illegal or you can't post anywhere else.
But hadn't there a couple based on Arweave actually? I remember at the very least one based on Arweave. And it was, I think the monetization approach was something like tokenize your videos and sell them or something, but still there was an uncensorable video sharing thing.
By the way, what happens if I store something illegal in Arweave?
Oh, good question. Strictly speaking, nobody is actually required to keep your data around. Like none of the servers are required. The game theoretical thing is that the one will just in case it gets requested so that they get the reward. But if you could, in theory, implement a protocol level ban list of stuff that gets people obeyed.
So nodes basically like self-censor. In a sense,
nodes can self-censor. I really haven't kept up with the ecosystem. I'm not sure if any actually are, but nodes could self-censor, or they could, in the same way that they can choose any type of any particular criteria to store stuff, right? Like a node can decide to store things that it thinks is not being replicated enough, just to have a higher chance at getting a piece of candy because of that, right?
Right.
But yeah, you could choose not to store something in Arweave.
So basically, they'll probably start doing that once there's an OFAC something.
Yes. Oh, absolutely, man. I mean, it is permaweb as long as the people paying you to keep it around are paying you enough.
Right. Okay. Well, that was a little bit of a tangent. We have a slightly special episode today, in the sense that we'll be talking about Gevulot, which is something we announced 3 weeks ago. I've been on vacation for 2 weeks, so my sense of time is very warped. But yeah, we announced it 3 weeks ago, and yeah, my thinking is that I'll like explain it to you, and then you can tell me all the things that are wrong about it, and hopefully we'll have an interesting discussion about why these things may or may not be wrong. But let's see how it goes.
Let's see how we can manage, because the one issue with that is that how we came about this topic originally was because we were kind of both converge on the ZKP all the things thesis. So I'm curious about how much of a devil advocate against Gevulot I'm going to be able to play. But let's try.
Well, like the thesis is one thing, but the sort of like design of a specific system is easier to be devil's advocate about. But let's see. So like maybe we should outline the thesis. We've probably gone over this in previous episodes. But
I don't think we have actually. We keep discussing this on Signal, and I don't think we ever discuss it on a call. Okay. Ever, at least since we started having the calls.
It could be. So let's just outline it. I'll give sort of mine, and then you can give yours, and we can. I mean, unless it's the exact same, but like I can go from there. So basically, like my thinking is that well, first of all, I think that we're reaching on the infrastructure side of blockchains, we're reaching kind of like some beginning point of maturity. I maybe maturity is the wrong word, but like we're the path to sort of the end state of what the infrastructure looks like is starting to look clearer. And I think it broadly falls into two categories. One is kind of this super fast global state machine, which is basically the Solana Sui, like that philosophy. And the other is ZK everything. The ZK everything, like the ZK everything means that every state transition is in a proof somewhere. Every bridging transaction is a proof. Everything is a proof. And that direction has the like basically it has almost unbounded sort of capacity to do things. Zero knowledge proofs or validity proofs are kind of like compression algorithms for stuff. The downside of it is that while it's very efficient to use sort of structurally, where you only have one person producing a proof and then others can asynchronously verify it, the proving times are sort of longer than what you can do in the fastest possible global state machine model. So if you like, I mean, this goes back to Solana's basically original thesis is like, if you need like financial data, like per tick sort of stuff, then the zero knowledge proof way is unlikely to be that. One last thing on that is that looking at these two models, it does seem to me like everything is a ZK proof thing. It looks a lot more like the kind of like world computer or like verifiable compute generically, while the state machine is more about like very efficient movement of data and synchronizing nodes. So that's maybe another way to just think of, or what that I think about it is kind of like ZK everything is like, can we build sort of like a global computer that can do almost anything that a regular computer can do? And then the fastest possible state machine is more like, can we do very efficient global markets, is maybe the distinction. But yeah, curious to hear what your kind of angle is on this.
Yeah, I came to it from two different sides actually, and it's a different thought process. So I just find it interesting that we both kind of arrived at the same conclusion. There's definitely the fastest thing wins side of things, and it's not just an issue of speed. It's not just an issue of raw speed, right? Not just an issue of how much transactions you can put out, but basically a factor of how smooth does this feel for users, right? And if things feel really smooth when you're using, say, a layer 2, but then to actually withdraw, this takes a week, the smoothness breaks right there. So that's going to be, I think, basically we're going to need extremely fast layer 1s if you want to onboard average people onto things. So that is one side of it. Now, the reason why I came to the ZKP was twofold. One of them is simply the fact that I just don't see the next order of magnitude of assets coming on chain without proper privacy. Like nobody is going to want to, like already founders' wallets are exceedingly scrutinized. Now imagine what's going to happen when people start putting buildings on chain and trading that kind of stuff. Like forget it. Like nobody's going to want to touch that kind of thing if they understand the implications of how they're broadcasting. Like we basically go back to the first description of Bitcoin that I read that really fit, which was like, it was like Twitter, but for your bank account. Now, the other side of this is that what I think is going to be a zero knowledge everything is because I don't really see a path forward for fixing bridges. I think bridges are going to end up being basically a massive honeypot, and you're going to be playing defense the whole time. And no matter how good your team is, you are going to screw something up, or somebody who's determined enough is going to find a way to break you. So I think that basically the only way to quickly move value in between chains is going to be eliminating the permanent honeypot in the middle. And this is going to be the way that it would describe to someone is this. It's kind of like a return to company script, basically, where a chain, let's say Ethereum, somebody on Ethereum issues some statements that they are sending this value over to this address on Solana, and something else on the other side decides if to honor that or not. And then through zero knowledge proofs, they coordinate basically a handover so that the value disappears from one end and somebody fulfills that on the other end. I don't really see a scalable way to do bridges without something like this, because this eliminates the permanent honeypot. It's just, can anybody fulfill this particular agreement right now, effectively? So that's how I ended up coming at that side. And the things on both ends, they could both be extremely fast ledgers, right? This could be how you move value from Solana to Sui if you want. But the transition in the middle is either going to be a centralized exchange for purely centralized stuff, like say USDC, you can probably just move through an exchange for any chain whatsoever. But any other value is going to be, any other large value is going to be transferred in this way. And not everything is going to be transferable, right? Like, forget about trying to use your CryptoPunks as collateral on Solana. Like, that kind of shit is never really going to work long term.
Yeah. Wait, I want to dig into that very last point a little bit. Why NFTs? Why wouldn't NFTs work specifically?
Well, the main reason that I see is that if you're going to need to have something on the let's say on the CryptoPunk example, you're going to need something holding that on the Ethereum side for a while, because you can't destroy it's not like with USDC where you could just burn or redeem or transfer this to an account. So something is going to need to be holding that punk, so that if ever controls gets transferred back to Ethereum, you hand it out to something else. And that something is going to be what ends up becoming a honeypot. So that something is going to have the same attackers coming at it that bridges are going to have, basically. The bridges have now.
But you could just destroy it on Ethereum and have a minting contract on the other side, which creates basically the same thing, I think.
Okay,
and then
so you could
go back the same way. But
you could, in theory, do it if the original asset supports it. You're not going to be able to do
it. Exactly. Like for old stuff, no, you can't do it. But the same applies to like fungibles to some degree. Is like everything is easier if the whole asset is designed to move over things rather than some sort of external party trying to create a mechanism, because then you never want to burn unless you know you can get it back with a mint later on somehow. So, but yeah, and I think the major or the bigger thing potentially with NFTs is like it's just not a big enough use case that anyone would be bothered
with the current version of NFTs. But again, if we're talking about real world on-chain assets, those are effectively NFTs, right? The building is not the same as another building, and I don't really see those things translating that easily from one to the other.
Yeah, but the issuer can just bridge those. Doesn't really need anything. But okay. Yeah, I think that makes sense. So, I mean, just to kind of quickly go over how this all relates to Gevulot. So Gevulot is a new L1 blockchain that we're building, which is, well, what we say is it's basically an L1 for deploying zero knowledge provers and verifiers as on-chain programs. On-chain programs here does not mean smart contracts in the traditional sense. So the way that Ethereum works is that you deploy a smart contract, and then when you run that smart contract, every single node does the same thing, and that's how you kind of reach consensus on what happened. In the Gevulot case, you deploy both a prover and a verifier, and only a small amount of nodes will be user configurable. How many run the prover, and then the rest basically verify, and verification is a lot more efficient because you can deploy, like, these provers are user generated or user created. It basically supports arbitrary proof systems. And the point of all this, basically, or what we're trying to build, is like the most efficient pipeline for proof generation, in a sense. It's like, if you think about, like, what is the optimal system for just running through that whole process, which is, you need someone to generate a proof and someone to verify it, and you need to return that proof to the end user. That's kind of what we've wanted to do.
Perhaps take a step back here and elaborate a bit on who you mean when you say user, because you said you can deploy a number of verifiers to deployers and that is user configurable, but it seems that we're using user interchangeable for the individual or institution that wants a proof generated and the people actually providing compute on the network.
They probably have some overlap, but yeah. So maybe start with the use cases. Basically, the use cases, let's say you have a ZK rollup, Starknet, Aztec, ZK Sync, one of the ZK EVM things, whatever. They all need to generate proofs. Usually one for every block. There's some more complicated constructions, but in essence, someone needs to generate a proof that needs to be verified on Ethereum. Now, the process of generating that proof right now is basically centralized. Most of them are thinking about how to decentralize it. And so what we want to do is basically build out a network that aggregates all that proof generation into a decentralized environment, because really what we're competing with is centralized proving. It's very compelling in a sense to go centralized, and that's very easy, but that, I think, breaks down a large portion of the whole point of blockchain right now. So yeah, we really need some solution for this. So then, going back to the user thing, so we have the sort of deployer, not necessarily the one using the prover. You use it by passing in inputs, and then you have, so you have the deployer and the user. They're distinct, but they're quite often will probably be the same. And then you don't need to run any infrastructure. You can just grab a prover from somewhere. You basically need to make no code modifications, assuming that it's like an isolated code base. So we have an example on the GitHub of the Filecoin snark compiled into our environment. And that took a little bit more work because it was very entangled in like the node implementation. But assuming it's sort of like a standalone prover, like most of the rollups have, and so on, most likely you'll just be able to compile it as is, and then just make like a small modification to be able to receive inputs in the way that we sort of transfer them in. Yeah. So one of the big things right now that is sort of like a strange dynamic of the market we're in is that it's first of all very obvious that there's going to be a lot of zero knowledge proofs. If all these products fail, at some point there won't be zero knowledge proofs, but if in the next 3 years there's going to be a lot of zero knowledge proofs. Yet is basic, like, almost nothing right now where you can be a prover. So you also have all these hardware companies like zero knowledge acceleration teams, which basically try to optimize the software or the hardware to do proving really quickly. Have all these validators, all these sort of parties looking to do proving, and all of them are just waiting for like some place to put their resources. And so this dynamic is kind of interesting because the rollups are not actually that close necessarily to doing like decentralized proving. Most of them have only just started sort of figuring out decentralized sequencing. So realistically, they're all just waiting for Alio to launch at this point. And Alio hopefully will launch this year. But you have all this capacity that sort of like could be utilized, but in some ways, like, there isn't a very easy way to deploy it into something useful. And so we are kind of trying to build a system to both aggregate what workloads do exist, as well as a system that would be so cheap that even if you're Starkware and you're running a centralized prover, it actually makes more sense for you to just outsource to this system than run your own hardware. And in that way kind of start opening up the market.
And also seems that it wouldn't be just for somebody like Starkware, let's say, it wouldn't be just an issue of cost. The concern here would be saying like, look, we're not the only one doing this thing. There's another group of people involved. So we are up to a point reducing a little bit of trust, or they're really spreading it out, right?
Yeah.
It's not just centralization with extra steps.
Yeah, exactly. And I mean, and that'll slowly start happening over time. Everyone will try to figure this out at some point. Aztec is kind of, I think, the furthest along in this thinking, which is why we're aiming to, so we're planning to launch a devnet in Q1, like a permission devnet, where we would be able to do Aztec proving and a couple other use cases. So we'll have like deployment and stuff, but we're just sort of focusing on a couple use cases internally so that we have like something to kind of feedback loop us. But it'll start happening. Thinking about it from the roll-up, so it's kind of like if you're a roll-up, you have a couple of options in terms of how to do this. You can either just say, not our problem, like leave it to the sequencers. You need to generate a proof somehow. We don't care how. You can like directly integrate with some specific service to do that, which I think is very dumb. You could try to force people to run the hardware themselves. You can never really force anyone to run hardware. Like nobody has any control of where the proof is actually generated. And so this is the problem with anyone trying to do like an application specific prover network or proof marketplace, is that like all your prover nodes might actually be using the same API. And so that's why like what you actually like, the only thing that makes sense is basically to leave it to the sequencer, maybe give them some nice defaults, but let them figure it out. And then ultimately the sort of end game comes down to who's the cheapest. So all these like prover network things or whatever, including Gevulot, like the real competitor is centralized APIs. This is why it's an L1. I don't know if this is counterintuitive to some people, but L1s are the cheapest way to do things in blockchain.
Ooh. And before we started, we were actually in a related topic that we may get back to, but keep going.
Yeah. So like if you think about a blockchain, like, I mean, a lot of people who design blockchains and think about blockchains think about this, but in case you haven't come across this before, there's like a way of looking at blockchains, which is basically how much does it spend, which is like the network rewards plus the fees in some sense that the users pay for the hardware and compute that they get. And I think very like, so the absolute cheapest, like, or it's not necessarily the cheapest, but the way to be the most efficient in terms of expenditure is to have the most optimally designed L1 for whatever use case you're doing. The moment you're using a smart contract on Ethereum, you're paying for all sorts of other stuff that has nothing to do with you. You're paying, in our case, you would be paying like, for a lot of re-execution you don't need. You're paying for congestion created by other applications, et cetera, et cetera. So that isn't really the way to do something where you need to be really efficient. And if you're competing with centralized, you really need to be efficient. So we're almost like applying the Solana strategy, not quite as dramatically as they are, but to another use case. And the strategy is simple. The strategy is have fees that don't pay for anything in the Solana case. Like if you've ever used Solana, that whatever you're paying is not the cost of compute. It's not the cost of a lollipop. It's not the cost of anything. Instead, you weight it more towards the network reward. And that way you get very low fees for the users. So you can see that as a form of subsidy from the network to make it very cheap. But even if you were paying the cost of compute, if you have the sort of optimally designed architecture on an L1 level, that will be cheaper sort of in an end state than, for example, doing it with smart contracts on some existing platform. So yeah, that's
okay.
why
There's
it's
a
an
lot.
L1.
There's a lot to pick apart in there, but let me see where do we start, because I actually want to I want to poke a little bit at the fee versus subsidy side of things. But let's stick to the technical side a bit, because first you mentioned that this is for arbitrary proving programs, not necessarily smart contracts. So maybe talk a bit about how you guys developed the Filecoin thing, or what do you see basically if somebody wants to, if Starkware wants to start using this thing tomorrow, what do they end up writing and how do they write it?
They probably don't need to write anything. They take their existing prover implementation. I think it's called Sharp, or no, Stone Prover, and it's, as I recall, written in Rust or C++. You can compile that straight into, so like programs in Gevulot are ELF binaries. They run as unikernel images in a Nanos unikernel, which is basically like a very small OS or operating system. It supports like 9 different languages. Like you can write stuff in PHP if you want. You shouldn't probably, but you can. And so you can basically compile it into an ELF binary and deploy it, and that's it. Like assuming it's like the code actually does proving in a relatively like isolated way, that should be enough. That might not be the most optimal way of doing it in the Gevulot context, but it's not going to be far off. So the execution environment, the unikernel supports multi-threading, supports GPU. So like,
Okay, now
yeah.
let's say that side of things, the unikernel, etc., comes in once I am going to take the task, right? I'm gonna run a node that's gonna process this thing. When you say deploy it, does that mean that they throw it out there at the L1 as a package and it gets saved somewhere as a task waiting to be picked up with some constraints on cost and how long from now the task expires? Like what does the package look like?
So the programs, like at least initially, the programs will just be deployed into sort of permanent global state. Because we don't really have smart contract state, we get rid of all the kind of like input data that we get for proof generation and that we need for verification afterwards. Our state growth is going to look very different than what it does for most blockchains. So the blockchain piece of Gevulot basically does like transfers, staking, deployments. It's not a huge amount of state to deal with. And then it of course includes the proofs that have been verified as well. But so you deploy it, and for now it'll just be there permanently. It's not a task in itself, it's just a program. There are a couple ways of doing it. Like you could like have it include a trusted setup, or you could pass trusted setup parameters in at runtime. So there's some sort of like different avenues to go about it, which affect how generically it can be used or how specific it is to your context. And then when you run it, you basically send the network a transaction with your inputs and like that program ID, and then that task, or that we call them like proving workloads, gets allocated to a random group of provers depending, like, and the amount is decided by how many you want. So you can have as much or as little redundancy as you want in a way.
You the person requesting the workload.
Yeah. And then those provers run it, they produce a proof, or if they don't produce a proof, they produce a fail. And then if they produce a proof, that proof is verified and then eventually ends up in a block, and so on. So one thing to maybe touch on here is that the user who's asking for a proving workload to be run, you pay for what we call cycles. So we don't have like EVM opcodes, like a very nicely constrained instruction set that we can price and like everyone can know what has happened. We're dealing with like a large variety of different kinds of hardware where we're running things in a small operating system on bare metal. Like there are thousands of possible combinations of how things go. And so instead of that, so like the way to think about it maybe is like the computation is not deterministic from the perspective of the network, or we don't at least assume it to be. We only care about, is there a proof that is produced that can be validated or verified? And so the user actually pays for something called cycles. So we measure the running time of programs by blocks. So we're going to use modern proof of stake consensus, like and a structured mempool, probably Narwhal, Bullshark, or something like that. So our block times will be a lot faster than any proving times are, especially since we have so little actual state. There might be blocks where nothing happens, basically. So we can do...
Interesting. You're using the block generation as a clock, kind of like
Yeah,
in the Solana kind of way as well, up to a point.
Yeah. So we use it as an objective measure of time. It's not like perfect, but if you can get it granular enough, it's going to be very close. And so the user kind of pays for a set amount of cycles, and then either that's enough to produce a proof or it's not. And so it's sort of up to the user to pay for enough cycles for the proof to be produced, and then the incentives kind of drive the provers to do it as quickly as possible so you don't overpay.
Interesting. Okay, so the cycles are not measured on, let's say, actual, whatever processing cycles or what have you. They're basically time between task being sent out and workload being sent out and fastest result coming back, effectively.
Yeah, it's like workload comes in, is allocated to this group of provers. They need to complete it, or they will run that program between block X and Y. Like they start at X and they end at Y, and there's either a proof produced or there's not. And they only get a reward from the network if they produce a proof. So they're incentivized to do it and not just say they tried. And yeah, that's how it works.
Okay, but what I'm getting at is basically just put up scenario, right? I'm running the prover on my... suppose actually that Joe Bob Online wants a workload. Starknet wants a workload. They say, I want this thing running at most 10 cycles and I'm willing to pay whatever, $10 for it. I'm running it on my laptop. Let's say that on my baseline hardware, it's going to take 9 cycles for the thing to run. But you have specialized hardware, so your specialized, more expensive hardware is going to spit out the answer in 2 cycles, for instance.
Yeah.
And in that scenario, what happens? You get reward, everybody else doesn't get anything because they came in late, or just to deal with the first step?
We distribute the reward, so we want to incentivize speed quite heavily, but we also need to sort of smooth out the curve so we don't get the same situation I described, or there's one massive prover that just does everything. So basically the first one to produce a proof gets sort of the largest portion of the reward, and then it kind of tapers off. But everyone in the group that was allocated that workload, if they produce a proof, will get some reward. At some point, if you were to have a massive, like pay for a massive group of people to do the proof, which wouldn't really make sense. But if you did that, then the rewards for the sort of last ones would probably be very small. But that's kind of the way to smooth it out a little bit, because what we want to do is, like, we want the hardware for proving to, and the software in a sense, to commoditize. And on the way there, we want to smooth things out until sort of like everyone has access to everything, or at least like it's not just one company or two. Like, we want the game theory to be a little bit more even, so everybody kind of like grows together towards some kind of equilibrium end state. And so I think that achieves it. You can also just choose to do it with one prover, which is sort of the most efficient in terms of cost, but like you don't have quite the same guarantees then. So that prover, if you do it with a single prover, they still have an incentive to produce the proof, but they don't have a lot of incentive to produce the proof like faster than the
Faster.
maximum amount of cycles you
Yeah.
paid for.
Yeah, that's the basically the potential centralization scenario was one that I was thinking of. Basically, where you as an extremely well-funded CK hardware startup basically just throws hardware at a problem to drive everybody else out of the market, and now you own the rest of the proofs. So okay, then the reward gets spread out amongst everybody that participated. There will be, I guess, this will drive people as whomever is running these provers to basically try and figure out whatever the sweet spot is of performance versus cost, right? Which
Yeah.
may be a non-trivial thing. It
Yeah.
will also have the impact that those requesting the proofs to be generated are going to have to figure out how many cycles this thing is likely to take.
Well, yes and no. Like, they don't really need to predict it, so they get the fees to some extent. There's still some design space we haven't figured out all the details, but like one at least model is that like even if nobody is able to produce the proof, the fees go to the provers that were involved in that. There's some nuances there, like it may actually be smarter to burn the fees if nobody produces the proof.
Yeah.
But regardless of the fact the user is paying for it, and so and like the sort of cost of a cycle will probably be like benchmarked to the real cost of compute with some sort of pretty default looking hardware setup.
Well,
So
but if you will as a network have to try and figure out some sort of basically
the
it seems like this
users need
is
to figure out how many cycles to pay for, and as a network we need to figure out how to help them do that in a sense.
yes, because what I'm
Yeah.
thinking is basically a potential economic attack here. Even if you burn the fee, if
Mhm.
somebody starts spamming the network with tasks that are impossible to fulfill in the time frame required, and they don't mind burning whatever the fee is, then they would basically be using up a whole lot of compute power where the people who
Yeah.
are taking the tasks don't get rewarded. Therefore, they're incentivized to take anything
But
but larger potential packages.
Yeah, but this is why we can't go like full Solana, where like the fee will actually be correlated with the cost of compute and not just like some random number that's far below 0.01. And so like yeah, you can always have if you assume an adversary who's willing to destroy endless money to attack you, then you lose probably in most game theoretic circumstances. But like if you have the real cost of compute, that is still a significant cost on actually doing the workloads.
Depends on the scenario and the design, right? Like say Solana was relatively, if you were an asshole like a year ago, Solana was relatively easy to bring to its knees with barely any cost because Solana is really cheap. so there is a certain value on figuring out that the least, and basically on having a floor on what somebody requesting a particular workload can pay for it, right? A reasonable floor, because that way it hurts if you have to burn a lot of it.
Yeah. Okay, that's a good point. So, like, you can make some assumptions on like there are zero proofs that can be computed within one block if the blocks are 400 milliseconds or something. Like that, you
Suppose
can
that
create some
you
constraints for the fees, which mean that you can't, for example, like spam tiny workloads that won't ever produce anything into the network and things like that.
or even medium-sized, say 10-cycle workloads for which I'm paying a tiny amount that maybe people will pick up if the network is not, if they are not getting a lot of work otherwise, but they will end up getting like basically poison workloads is what I'm trying to think about here.
Yeah. Well, I mean, I think that does come down to just how cycles are priced.
Yeah.
So cycles should be they should be priced high enough so that spamming is expensive, but low enough so the network is cheaper than everything else in the world. Because like this is one thing that like I think the cryptocurrency industry really needs to, I think, start doing more, is like we need to sort of, I use the word attack, I don't mean that in an aggressive violent way, I mean like in a business, MBA's reading Sun Tzu kind of way. I think we need to attack kind of larger external industries and industries in general by playing the cost and efficiency games that everyone else plays. And in some specific areas, we can do that very effectively because we have so much control over how kind of a token performs in relation to it being a payment token for something, is its utility and an asset, and like we can find new balances that kind of allow us to make things cheaper than they should be, at least for some periods of time. Like this is how
Only because we're printing money in a lot of cases.
well, exactly. But but this is my point, is like, PayPal or all these companies that have grown by basically giving out free stuff for a long time, right? This is every tech company in the world that's like above 1 billion has been doing a lot of shit for free for a long time on VC money.
Yes,
we
which
need
is
to
which is arguably not the same. Right, in a situation like, say, Solana, for instance, the equivalent here actually to what PayPal or Uber did, right, of subsidizing the fees themselves, subsidizing transport fees, would be if Solana was sending validators a certain amount of USDC that comes out of the treasury that they raised from VCs, right? But they're not. What they're doing is printing SOL tokens that just materialize and that they hope people will appreciate further down the road. And this would be closer to if Uber and PayPal had been subsidizing the transactions with their own shares.
Sure, but I'm saying in a centralized context, they're handing money out, like they are subsidizing it with their own shares. They're selling shares to investors and then using that as subsidy. Like it's a subsidy. It's just like done via inflation in a specific context. And I'm not saying that the exact mechanism is the same. I'm in fact saying that we have more opportunities to design the mechanisms for doing this in the blockchain world, and I think we should utilize that, because we can kind of vampire attack industries. Like I think what people very much underappreciate about Solana is that thing is cheaper than anything in the centralized world for moving money around. And like that's exactly what we should be doing. We should make everything just like so much cheaper that everyone has to use it. And then like eventually, yes, things need to like play out, and you probably need to increase fees to something, and the end game gets all murky. But like step number one should be get everyone on board. Like this is the tech playbook 101. It's like get all the users
Actually,
and then figure it out.
It's not only just an issue of making it cheap, and we have. I do think that we have gone on this one on the pod in the past, but just in case, it's not an issue of just making it cheap for people to come in and, I don't know, send money around. It is because stuff being cheap encourages experimentation. So yeah, I would never have run a Mango Markets liquidation that's just basically throwing transactions out there and hoping something hits if Solana wasn't stupidly cheap, right? And the fact that you have more people actively using your system means that the system, on the case of something like Mango or Drift, means that the system is a lot more resilient to stuff that like a liquidation cascade than otherwise would be, because you're distributing the risk across a whole bunch of people for whom the cost of getting involved is negligible, basically, which is like that's a magnet of, and this, by the way, brings other benefits. Like the same people who are running a liquidator might be able to spot issues in your code, right? It brings extra eyeballs. It brings a whole bunch of network effects that otherwise would not exist if it is only 3 people who can afford to get involved.
Yeah. Yeah, exactly. And like, well, the other thing it does is it makes possible use cases which might not actually make sense, which is sort of like a double-edged sword. But that's also the same as experimentation, you know. So,
But that
like,
that
and
is
as
and
long,
that is the same as the VC side of things. I mean, we had like
mm,
web ban and shit in 2000s. So,
yeah, like I think that's actually really important. So, like, I'm perfectly okay with like blockchains going more towards sort of like being an asset in a sense, you know. Like, I think Ethereum is going more in the direction of Bitcoin in some sense, where their focus is in
okay.
designing the sort of revenue streams and appreciation mechanics of the asset quite a lot. The ultrasound money, blah de blah, the, you know, burn, like what's happening to the supply, that's fine. And like that it's good that people are doing that as well. But I think if you're going for like, we're taking over mainstream compute, like if you're still a believer in the world computer vision, which some people call me naive for being, but I don't know, I still think that's what I want. Maybe no one else wants it, but I want it. Then I think you need to play those games. It's like, you know, Amazon free credits like games. You need to just onboard users very aggressively. And yeah, I think like Solana is doing that in some ways for financial markets, which is an exciting, like an exciting approach to see how it goes. Because like at the same time, you know, they do, I think, need to like up their game in terms of their perceived reliability to actually get any like production. Like Swift is not going to start using them unless it's like really really guaranteed that this thing works, or they'll have backups or whatever.
Yeah, the thing there is not even. I mean, we're getting a little bit of the Gevulot topic, and we can go back there. So let's. I'm not going to rant about Solana. We can do that later. Keep going. Let's get back to let's get back to where we were. Where were we actually? We were on the potential like for an economic attack if this thing is too cheap. Now,
Yeah.
however, I don't think that they're quite the same concern necessarily applies to Gevulot as we're talking about Solana, mostly because this is not going to be a mass market thing, right? This is going to be it's going to be a particular type of business that ends up integrating with this thing, and a particular type of user that is actually willing to both spend the mental bandwidth to figure out whatever the sweet spot is for them of compute cost versus whatever they're getting from the network. So there's going to be a appeal to a very, let's say, both technically savvy and technically involved users. Or am I
Yeah.
wrong?
Yeah, it's not a retail play. Someone
Yeah.
described it quite well. It's like infra for infra. And this is partly a reflection of I guess me and equilibrium, is that, you know, like we just like spending time talking with engineers, and so and we're not that, you know, like great at sort of traditional marketing or like retail plays. And so we've designed like probably one of only a couple different blockchain configurations that actually make sense, where the end user is specifically the kind of engineer that we want to talk to. And so
Yeah,
it'll
like
probably
basically
mostly
the kind of people that you wouldn't mind selling something to.
yeah, like and what's nice about it as well is that they're going to be very selective and very critical. Like, it really does need to serve them in order for them to pay for it. Like, this is going to have very different dynamics. But yeah, so mainly like projects, sequencers. Like, it's our intention is like it's nice because there is a pain point that's like very easily described, or it's like somebody needs to do proving, and proving right now requires quite a lot of hardware and is expensive. Like, that is just like we take that pain away in this network structure.
No,
That's nice, although that pain point is very abstracted in a sense, where it's like it's the blockchain industry, which sometimes isn't quite sure what the pain point it is solving for, but then we solve a pain point for like like a couple layers down of participants in that industry. And then the pain point is very clear. But it does have this sort of
I wouldn't say that your pain point is abstract. I just say that your pain point is for a very particular niche. But
yeah.
which getting back to our whole discussion on subsidizing and whatnot, given that you said, like, we want to drive the cost down, etc. Does this actually need to be subsidized, given that there is already a pain point and this people, like these clients of yours, these potential users of yours, already have a cost? They just need to figure out if it's worth not running that cost themselves.
Yeah, probably like in the very early going, it doesn't need to be subsidized. Like anyone who's running a prover right now, they're not running it anywhere near kind of capacity. um, all the yeah, like there's a lot of unused hardware, and so there's a lot of kind of compute that would be willing to do work for maybe less than sort of they would if they were at capacity. At some point, though, that will probably evolve more, and there will be opportunities for centralized provers to run near capacity. So at some point, maybe it needs to be subsidized, but it's unclear. It's hard to know the exact dynamics because it's a little bit unclear what the kind of preferred market structure is going to look like until proving opens up a little bit more. So Aztec is probably like they're not launching for a while, but their testnet will probably be the first to have kind of decentralized sequencing and decentralized proving working in some fashion, and then we'll start to see sort of the dynamics that emerge, but I think it'll take a while. One question I have for you, which is interesting, is do you think zero knowledge proofs are going to break out of Web3? And by that I mean,
Oof,
like, do you think there will be use cases in Web 2?
good question. I am not entirely sure. I would say that at the point that if we're just talking about Web 2 as in the old corporations dealing with corporations kind of things, basically, to narrow it down, I think that corporations dealing with corporations already have an element of trust anyway, and they already have established channels. And I think that zero knowledge proofs have a value where you do not want to have to share information in order to get the result you want, on when you can rely on any sort of trust. I don't see the old way of doing things moving towards that direction in the near future, particularly because I suspect that a lot of the organizational incentives are going to be around keeping the old structure going, right? There's I think it's Clay Shirky's line of basically an institution will try to preserve the problem for which it is the solution. And
Yeah.
a lot of these companies have people basically there just to preserve the trust situation. So it's a similar thing.
Yeah. So I'm going to say I'm not sure, but one thing that kind of like caught my eye. Have you seen this thing called Zephyr?
I don't believe
Zephyr
I have.
Exchange. I think it's at Zephyr Exchange on Twitter. They're like basically doing a fiat on ramp using Stripe where you like send some money and then you take a zero knowledge proof receipt, like of the receipt, and then you post that to a smart contract, which then unlocks tokens.
Okay. But
And that
that's still not a Web 2 thing. I mean, it's a
no. But it's not, but it does, I think, kind of point to the fact that there might be some Web 2 things. Like it's also not clearly a Web 3 thing in the sense like it's only like partially on chain. Like there's utility in the zero knowledge proof because we can prove something that happened off chain, right? And so couldn't you use that in another context? Like you could just as well have that be verified by some company and they
hmm.
do something like I don't know. Maybe it all maybe that's the extent of where zero knowledge proofs like do stuff is the sort of like the boundary between blockchain and the rest of the world. I don't know, but
Okay,
there
but
might be something.
The thing is, at that point, if we're talking about having a third-party verifier, let's say, that point, I think that that case would be already. I mean, it's basically kind of like the self-sovereign identity case. You're just dealing with a signed statement by a third party, right? Like this other company says that I am over 18 years old. It doesn't need to be a zero knowledge proof. It's just a signed statement that they have seen an ID or something. That's why, like, zero knowledge proofs per se, I would have to think more about where they would use it. I think that signed statements are going to take over a lot of the. If that sort of thing were to happen, signed statements would be the way to go.
Yeah, that's fair. I mean, it would be very nice if like everyone just ran standardized public public key infra, right? Like that would
Yeah.
that would be cool. But it's interesting because like so much of the traditional world basically already does that, right? Like everyone is running signing infra, but it's just not standardized. like if we just remove all the like blockchain stuff, like simply just having some kind of standard for signing as some entity, like that would already be an improvement. I guess that's what like I don't know PGV kind of tried to do, but
yeah. Also, the thing is that end of the day, right? Zero knowledge proofs are useful, particularly when you really want to be sure of something before you take action about it, because there's going to be no recourse, right? Like I really want to make sure that you deposited money somewhere without having to see the account, so I can send money somewhere else myself on the bridging scenario.
Well, alternatively, also where the recourse is expensive.
What recourse is expensive as well, but the thing is that there's already like the traditional, the meat space things, let's say, in terms of legal recourse for an agreement, legal agreements for a lot of things. And I expect that also the stuff that concerns them is a lot fussier and can't be as easily evaluated as is there a certain amount somewhere, right? It's more about, did that company fuck with the spirit of this agreement or not? I don't know. I think at the very least, I think that those are the really expensive cases in the meat space.
Yeah. Well, I think it remains to be seen. I think that's one of the more interesting questions of kind of the next 10 years is because zero knowledge proofs, as we've spent this whole hour talking, they do seem very like fundamental in some ways to the both the implementation and the ethos of the blockchain industry. And it, like I wonder if they end up getting utilized somewhere else in some context that isn't this, that maybe we can't foresee. The answer is probably yes, but we won't even hear about them because no one's going to make money doing them. So no one's going to hear about
them. It's also a probably yes, but when kind of thing.
Yeah.
Basically, I would be surprised if that happens ahead of crypto and decentralized rails replacing a lot of the traditional infrastructure.
Fair.
Because at that point, you already have this is how this fits into my way of doing things, right? You're not asking them to take a leap further. So we'll see. Yeah. Let me think about it. Maybe I'll come up with some random crazy use case that actually fits.
Okay, so well, we can pick this up next time if we have nothing else to talk about. Now I do have to jump though, so thank you.
This was a fun one.
Yeah, thank you everyone for listening to episode. God, what is this? 16.
I actually have no idea. No, I think we're like up to 20 now.
Are we? Let me. I need to just check before we sign off so we can do a little celebratory thing. 21, episode 21.
Wow.
Of the Spelunking podcast.
Like the podcast is old enough to drink in the United States now.
I know. Exactly. Thanks everyone who's been supporting us all this time. And we'll see you next time.
And I'm pretty sure our audience will only grow as our topics just get more and more obscure, right? It's not like SPF trial discussion or something.
As we start sounding more old and demented by the month. All right. See you guys. Bye.